All right, we're gonna take what we did yesterday and then extend it into a new one. Today's eventually we're gonna look at irrational squares. Irrational are when they repeat, or excuse me, they do not repeat. So for example, if we took the square root of 20, the answer would be 4.47213595. It just keeps going on and on. So we want to take what we did yesterday and see how we can break these down into a simpler form that's not this irrational decimal. So for instance, if we took square root of 324, we want to do what we did yesterday and find perfect squares. One doesn't help us so much, but any of these numbers, 36, 49, and so on and so forth, we want to find any of these that can go into 324 so we could break it down and make it simple and make it as far as we can go. The biggest you can find makes it easier, but if you can't think of anything more than 4, so on and so forth, that's fine. But we want to find a number that would go in that would help us out. So any different way you can start. I don't know why 9 is calling to me, but 9 is calling to me. So if we divide that by 9, so we would get 36. 324 is the same as 9 times 36. What's the square root of 9? 3. Square root of 36 is 6. So this was 18 is the square root of 324. That's what we're working on yesterday. Today, they're not going to work out the same way. So let's take 20 like we had right here. Is there anything from this list that would go in 20? 4. So we want at least one of them to be a perfect square because we can take the square root of 4. Yeah, there's 2. 5 does not break down. So this is our simplified answer. 2 times the square root of 5, or 2 radical 5 is what they will say. It's simpler. Is it the perfect answer? No. But it's not a decimal that goes on forever, and it's simpler. It's the same as if you had 4/8. We could simplify it down to 1/2. It makes it a smaller answer, easier to deal with. Part of why we want to get it in this form, in a few days, we'll have problems like this, where we kind of treat these like a variable. They both have radical 5s. How many radical 5s do we have? 3 plus 2, so we have 5 radical 5s. That's part of why we want to get it into this simplified form, so we could possibly combine them and make them a little bit easier. So let's take some more of those. All right, square root of 75. Anything from that list that would go into 75. 25. So we have 25, and it's 25 times 3. Square root of 25 is 5. Radical 3 does not break down. We always want to put our simplified coefficient out in front. So we're not going to write it like this. We always want it to be in the front. So that way we know. It's kind of like with x. We write 5x instead of x5. All right. If you might see one like this where it starts with a number out in front, we do not have to worry about this until we're done. So you just bring it down here. 112. What we think might go into that. If you're not sure, let's start with 4. Okay. 4 will work, I know that much. There might be something else, but that's okay. 2, 8. So now we have 28. Can we simplify 8 down anymore? What could go into 8? 4 and 7. So we're going to bring all these down. Square root of 4 is 2. Square root of 4 is 2. And then that's radical 7. So now we have 2 times 2 times 2, 8 radical 7. Let's come back up here. We could have apparently gone 16 and 7, which would got us. It saved us a step, but do we get the same result? So when we have that 2 out in front, it's us 8. So there's not an exact way to do it. Like I said, the larger you can find, it will save you a step or two. But if you have, it's the same way we're reducing a fraction and you don't see that 8 goes in and you divide by 2, it's not wrong if you keep dividing by 2. It's just more work. Okay? So you get the same result. It's just if you can find the largest number, you can save yourself some time. All right, do one more. And some of these, the simplest way to do it is just start going through here and see if you can find anything like 891. What do we think from that list might go? I mean, you can just start trying. I'm gonna cheat. It's gonna be 81, but let's say you didn't see 81 and you went with 9. Would that have been wrong? So it could have been 9, 9, and 11, but so that's 9, radical 11. So like I said, just start going through your list. 9 might have been easier. That would have given us 91. So that would have given us 99. And obviously we could look at 99 and go, okay, that's 9 and 11. So we would have still came up with 9 radical 11. So it's not wrong either way. But this list will be very, very, I mean, you can then be at 121, 144, and so on and so forth. All right. So I'm not wanting you to write up as the decimal. All I'm wanting you to do, so for that part, we're only going to do section A. Section A is just where the directions will say simplify. Simplify means take that radical, excuse me, right here. Take that radical and make it into a simpler, smaller number. Okay, so page 522, 523. And again, you won't have a calculator. So sometimes finding the smaller one might be easier because then you'll have to do your division over on the side anyway. So 522, 523. 1 to 29 odd. 522, 523, 1 to 29 odd.